they hear any of the beginning or no?
I don't think so. It didn't actually start. It didn't
Okay.
start on the YouTube side.
Hello, this is the presentation for the introduction to Python. I'm Catherine Lannon, and I'm a senior at William & Mary, double majoring in computer science and data science. I'm also the president of the Society of Women in Computing, or SWC, which is ACMW chapter on campus. ACMW supports and celebrates and advocates for the full engagement of women and minorities in all aspects of the computing field. SWC aims to meet these goals and seeks to bridge the gender gap in computing-related fields. We also seek to act as a central organization for women at the college to provide resources and opportunities for women to network, foster relationships, and share their experiences in computing. If you have any questions or want to join, well, I'll have the contact information at the end of this presentation. We will be introducing Python in an Hour of Code format. Hour of Code is a global movement that encourages people of all ages to learn how to code for an hour. We will be doing this through a Trinket tutorial so that you do not have to download any applications to follow along. Computer science in general is the study of theory, experimentation, and engineering that forms the basis for the design and use of computers. It's basically a problem-solving mechanism. Programming is the process of creating instructions that a computer can understand to carry out certain operations. It's basically applying the theory and concepts to the real world. Python is a programming language, and it's one of the 3 most commonly used. It's widely regarded as the easiest programming language to learn, as it is close to human readable language. Python can be used for a wide range of applications and has been used to build some of the well-known applications you can see in the image to the right. We will be going to this link here, and I will pause on the screen so you can follow along and go to it on your browser. While I'm waiting for that, I will mention Python is an object-oriented language. That means it is based on the concepts of objects. So each object has properties and attributes assigned to it, including procedures and methods. These objects will then work together to build and create the functionality desired. I will pause here a little bit longer so that you can go to this link. I can also just put it in the chat, and I will do so soon. So I just put it in the chat of the YouTube video, so you can click that link and put it in your browser if that's easier than typing it in. So now you can see the link that you would go to. I'm just going to go up to this one on the top. I should mention as we go along, I will be looking at the chat for any questions. If you have any, I may miss them, but I will always come back to it. So just feel free to put them in there, and I will be checking it occasionally. So continuing on from there, the first thing you will see here is this. This is going to be your code editor. So this is where you can edit any lines of code that you need to change the functionality that you will be running. It should be noted that Python runs things from this line down unless it tells you to change what line you are going through. So I'm there if you are confused. This code editor lets you change anything. You can run the script by just going here and I'll click run. You can also run it through the console, which tells you what line it's running there as it's running. This is also your shell. Your shell is basically a user interface for accessing an operating system services and can involve like command line interface. This is where you can have users input something during the script. As we are going to be using a library that deals with graphics, we're also going to have a graphics window, which is right here. And you can see like the Let's Learn Python there. As I mentioned earlier, we go line by line, and Python is white space delineated. So that means each new line is going to be a new line of code. And then also, if you have a function like you do here, it's indented to indicate that this section is a part of this definition of the function. I will be going over more of that later. We're going to be continuing on to just meeting Tina. Tina is going to be the instance of a turtle object that we will be creating and using throughout the rest of this workshop. So here we're going to import Turtle. Turtle is a library that contains a class of turtle objects with the methods and functions already set up, so you do not have to use those. We create an instance on this line of where we set Tina equal to the instance, so Tina will have all the capabilities of a turtle. Then we set the shape to be a turtle, so you get the cute little turtle image, and then you can just do a quick line of code to do some functionality in there. And now we're just going on to the next example. So moving is our next example. These are two methods that come with the class. So turtle objects have the ability to move forward and backwards and turn right and left. Both of these methods take in a parameter. For forward and backwards, this parameter indicates how far Tina will move forward or backwards. And then left and right take in the amount of degrees it should turn in that direction. So right now we have it's moving forward, left, forward. To complete the square, we would just need to do Tina dot left 90 and then Tina dot forward 50, and we would complete it that way. However, I do want to point out here there is multiple ways to code the same thing. So instead of doing this, I could have also done Tina.right 270 and then Tina.forward. That would have gotten me the same thing. So also, what I just did was commenting out a line of code. Whenever you put like the hashtag in front of a line of code, that means when the script is being run, Python will automatically jump over those lines and not execute them. So it will not do these two, but it will go to here and run these two instead. It allows you to add comments or just indicate if you're doing something, what that line of code is doing. So if you're working with a partner, they will also be able to understand the functionality of that area. Moving forward, we are going to start working of other things. So right now we're just having it write hello there, but now we wanted to have you write your own name. To do that, we're going to add something that so we can enter it in our shell, and when we hit enter, it will take that value we put in and show it here. To do so, we're going to be introducing a couple of concepts. The first concept we're going to be introducing is a variable. A variable is a named piece of computer memory containing information inside of it. Variables can be changed and manipulated and are able to store various types of data, including integers, floats, strings, and booleans. Some examples of these is like x would be your variable name, and your variable value would be 3, and that's an integer. Another example, you could set y equals 2.2, which is a float. You could do a variable name school and set that equal to WM, and that would be a string. And you can do spring equals false, and that's a boolean. These are just different ways you can contain values and store them for later use. In this case, Tina is actually going to be a variable, and it stores the instance of a turtle object, which is more of a complex variable than what I just specified, but it is still a variable. Your name here is going to also be a variable, and the single equal sign is an assignment of a value. So when we're doing your name equals something, we're assigning this variable name a value that it will point to in memory. This input is a way to read data from the user. Inside of the parentheses is the prompt that will be displayed in the shell that tells you what is expected and tells the user what is being requested from them. What you type in that shell as a response to that prompt is then will be returned as the value of this line. So we're going to basically set your variable equal to the value returned from this prompt. That means you do have to be careful of what users return because they may not always return what you expect them to. This is also an example of a command or method, which is a reusable line of code that performs a specific task on objects. The syntax has the parentheses at the end of it, which can have like arguments inside of it. For instance, we've seen an example of those with the forward, the pen up here, and even the turtle. Those are all methods that you can call. So in this case, this is getting this input and returning it, and then we're calling this variable here to get the value. So when we print it out, we have it there. Continuing on, in this case, we're doing the same sort of thing. We want to store the result of what we should say and then say that. Right now, this is a string that is being stored as this variable name. However, we want the user response. To do that, we're just going to use the same thing we did above and do input with our parentheses, and we can keep the what should I say because that indicates the prompt to the user. And then we'll have it here, and then you can type whatever. I'll take hello, and then I'll type run. And there we go. Moving forward from there, we're going to be looking at colors. This is just using more of the functions that are built in, and you can do green here. It's just another attribute you can set, and then it can be used by the turtle object. So I'm just going to continue on again. Once again, this is another function and functionality of the turtle object. Pen up basically means you're not going to be drawing while you're moving. Pen down means the turtle object will have a line after it. Whatever you last do will be the standard until you change it again. Go to is just a movement using the coordinates of this graph. Some of these coordinates can change depending on what graphing library you're using, but in this case, this is how it currently works. I'm going to move on. So again, what I was talking about is the grid. This is a nice way of just showing you where things are. This is 0, 0 according to this thing and so on and so forth. And this is the grid, as you can see here. And this is just something you can keep in mind. It's always good to know where your center is and other points so you can do things in relative to that. So continuing, I'm also going to skip over this, but this is something you can play around with. It's just using more functions to draw different things. You can draw whatever you want, and honestly, I challenge you to draw something like a house or some other object. So now we're going to be moving on to lists. Lists are mutable and changeable and are an ordered sequence of values, and these are going to be stored in memory in this order. They're defined with square brackets and items in the list are separated by commas within these square brackets, as can be seen here. Once again, you have your variable name and you're setting it equal to that result. Lists can store all different types of values, and they can even store other lists. Moving on, we're going to be using these lists for loops in this case. A loop is used to perform a series of instructions until a certain condition is reached. You iterate, which is repeating a process to generate a sequence of outcomes to attain the target goal, and typically you iterate either over a list, which we're going to be doing in this case, or a range of numbers. I will briefly show you a range of numbers. So you can do for I in range, and then you could either just put for, which means Python starts with 0, so you'd be going and automatically increments by 1. So in this case, you'd be starting at 0 and incrementing by 1 until you reach the value that you put there. In this case, it'd be 0, 1, 2, 3, but it wouldn't ever get to the value of 4, because as soon as the value is 4, that means it's equal to this here, and it will exit the loop. You also can change what it starts at by doing a 1, 4. That means it will start at 1 and end at 4. So it will be like 1, 2, 3. You can also change how much it increments by. So this means when you have 3 parameters here, this means it's going to step up each time by a value of 2. And then to add functionality to this loop, you're going to have to do a colon, and then the white space is important because that indicates what is a part of that for loop. And then you would just do some function call or thing in here. I just type G's, which doesn't work. Going over this again, I'm now going to focus about going over items in a list. So many data structures in Python can be iterated over to make use of information that they're storing. So looping over a list applies the same set of procedures to each item in that list. So for this thing, these are our items in our list. So each time we're going through, we're going to take one of these and then do these sets of instructions for each time we go in there. So for each one of these, we're going to go 1 times 10 and move forward that distance, and then turn left. And do this until we've gone and done 10 times 10 and move forward that amount and turn left. As you can see, this is the ending result, and you can just run it for yourself. This is a nice way of condensing the amount of lines in your code and not repeating unnecessary amounts to do the same functionality. For instance, here you can see we're repeating this many times, but the only thing that is changing is this line here where we're indicating our color changes. So instead of that, we can have the same instructions here in a for loop where we just iterate over the colors themselves, so that we're not having we're condensing the amount of lines without losing any of the functionality by just adding a loop. Loops can be for loops. There's other types of loops as well, but in this, we're going to only focus on for loops. So once again, this is another example of what a for loop can do, where it iterates over a list, changing the colors and adding the same functionality each time. You can test this out and try and do some different functionality with it as you wish to practice. So as I mentioned earlier, Python is an object-oriented language, and turtles are objects. So an object is a collection of data, variables, and methods with functions that act on those data. A class is a code template for creating objects, and you can use the keyword class to create one in your own code. An object is an instance of a class. So here we have our class. This is our instance, our object, and then we have this. So that's what Tina is. One thing I did want to mention here is you can always look at what functions and methods and so on are available in your different classes that you're importing. In this case, you can just click on modules and do it. Sometimes you may have to just search it online, but in this case, you can go here, you can click on turtle, and you can see the different functions, definition of the function, and some of the examples of how it can be used. And you can just play around with going around there and seeing all the different options that are available to you. So as we mentioned before, Tina is one instance, but you could have multiple instances of the same object in one script. So here we're just doing what we did earlier for one, and then we're creating a second instance, Tommy, and doing the same but opposite direction. This allows you to have multiple objects and do multiple different things using both turtle instances. So here we're going to be introducing even another concept, which is if-else statements. Conditional statements are where code will or will not run at that point in the program based on whether certain conditions are true or false. So in this case, we are going to be taking input as we did earlier, which we will be getting in our shell. We are going to be making sure it is an integer because this statement that we want to be doing, we're going to be checking if the values are equivalent or not. So they have to be an integer because 2 times 7 is 14. One thing I wanted to note here is a single equal sign is when we're setting something equal. We're assigning a value. However, when you see double equal signs, that means you are doing equality and checking if 2 different variables are pointing or have the same value. Another thing you can mention is there is a keyword is, which will check if 2 variables are pointing at the same object in memory. This is different than the same value because for instance, the number 1 can be stored multiple times in multiple locations in memory. So not all variables that have the value 1 will be true when you check them with is. However, they will be true with is if they're pointing at the same one in memory. I wouldn't worry too much about that there. I just wanted to mention it for your information. Also, you can add more statements onto an if statement by doing an and, where this has to equivalent to true, and this other side have to equivalent to true to get what is into this if statement. You can also do or, where as long as one side is true, you will go into the statement. So this conditional statement for the if only goes into this segment of code, which you can determine by the white space, by the indentation level. The indentation level indicates that this goes to the if statement, and this will only go if the condition was true. So if I guessed 6, it wouldn't go into this if statement because 6 does not equal 14. So it would go to this else statement instead. But if I did guess 14, we would go into this if statement because it would be true. Moving on from there, we're going to add elif blocks and try except blocks. So if blocks check your first condition. Else blocks do something if that first condition wasn't true. But you can add more blocks and conditions to check after your first one with elif. So how elif blocks work is you check this first condition, and if it's false, only then will you check this next condition, and so on. You don't always have to have an else block, so you can ignore that. And if you don't have an else block and none of these conditions are true, you just wouldn't do anything. A try except block is a way to catch errors and handle errors smoothly. So instead of just failing and failing with a general message, you would fail smoothly and be able to give more feedback to the user about what was happening. And this is where I mentioned that users don't always input what you expected. In this case, we're expecting an integer for the age. However, I could type in 5. 5 is not a number, so when you do this block of code, when you try and change the string 5 into an integer, it would fail. But this except block would handle that failure by writing, I don't think I understand that age, are you using numbers? And that gives me, the user, feedback about what may have gone wrong and what I should change and about how I was using it to get the correct functionality. So let's say I learned that and I go, okay, well, I'm going to type in the number 5 this time. Well, now we're going to go through this block and do the correct functionality. You can try play around with this, but it's always good to do a try except if you're handling like user feedback or something else where you don't know if you're going to get the result you are expecting. Once again, this is another example of try except and if statements, elif statements, and else statements. I'm not going to go through this, but you can on your own time and learn more about it. And if you have any questions, you can always let me know and I'll answer them. But we're going to be moving on to functions. Functions take arguments. They're also may being no arguments and perform some action using those arguments or just on in general. Functions make code reusable. So instead of having to write the same thing over and over again, you can create a function for it and just call that function whenever you want to use that method. Common high use functions like input, what we were using earlier to get user input in the shell, are frequently built into the language, which are keywords, and you can look at those keywords by like searching for inbuilt functions in Python. If you can't find a function that suits your needs that has already been created, you can always make your own, which makes it a user-defined function. Functions are object independent, so they aren't reliant on a class. Looking at this here, this is just the general. This is how the general definition and the syntax of how we create a function. So you always have your definition or DEF. You have to write DEF, which indicates that you are defining a function or a method. Then you have your function name followed by parentheses. In these parentheses, you could potentially add variables you would want to, variable names that would represent values that you want to take in as attributes. For instance, if I want X and Y, I would do that. When I called it, I would have to put some value for X and Y to call that function. Then you have your colon after those parentheses, and once again, you are going to use your indentation to indicate what lines of code go to this definition of your function. So in this case, we are going to be doing Tina left, forward, left, forward, creating a triangle. Then to call this function, we are going to have to put the name of the function and then the parentheses. If you run that here, you can see it does as expected. Something else we can do is to work with the idea that Tina is an object and it is an instance, and you could have multiple instances. You can take in that object as a parameter. For instance, let's say we wanted to define a square. So we do def function name is a square, and then we're going to do t for turtle as our attribute. From there, we can use our loop because we know squares have 4 edges. We can do for I in range of 4 to do this 4 times. Remember, we start at 0 and go to 3. We're still doing it 4 times. We're just never going to get to the value of 4. And then we can do t.left, move and turn 90 degrees, and we can do t.forward and 50, like we did earlier. This only works when the value of t passed in is a turtle object, because these methods are based on turtle objects. But to call that, we would just do square, and then we would pass in Tina. So now when we run it, we're going to get our triangle, because we did that there, and then we're going to get a square. Is any questions on that? I'm checking the chat now. Okay. I will move forward then. So this is another example of a function that you can do that has attributes. In this case, they're taking the horizontal and vertical location you want to, quote unquote, make a cake at, and then calling that function multiple times. So instead of having to do all this set of method calls on Tina all those times, you can instead create a function and just call that function name 3 times. That shortens the code and also makes it less repetitive. As I mentioned earlier, with what we did with square, you could also do a t and be able to specify what turtle object you want and change it. But if you were doing that, you would have to change all the Tinas here to t. And then you could do this, make cakes for any number of turtle objects that you created. We're not going to be doing that here, but you can play around with it on your own if you want. Here's some other functions that you can play around with and other examples you can take a look at. But that is going to be the end of our foray into this tutorial. If you have any questions on it, please let me know and I'll go back to anything you have questions on. In the meantime, I'm just going to share how you can contact us. So to contact SWC, you can use our email. You can also follow us on our Instagram or Facebook page. We'd be more than happy to answer any questions you have on computer science in general, this workshop, or how to join SWC and meetings in the future. Thank you for coming. Also, if you wanted any hints about some other libraries and different Python classes you can take a look at for your hackathon projects. If you wanted to do something about data science, some main libraries there are Pandas and Scikit-learn, also NumPy. If you want to do web scraping, 2 libraries you can start with is Scrappy and Beautiful Soup. If you want to do some sort of game, there's also PY Games. There's a lot of other libraries out there that you can use, but those are just some good, cool ones that you can start with. Also, we didn't require you to download an IDE for this workshop. However, you will probably need one when you're working on your own. My favorite is Visual Studio Code, but that's just a personal preference. There's no harm in using any other ones. There's also Atom, PyCharm, Spider, which is a part of the Anaconda package. It's also Jupyter Notebooks, and a ton of others. Just find one that you like. And then also, if you're going to be working on a team, I'd recommend using version control. My favorite one is GitHub, so that both all teammates can work on your code at the same time. And you have a version history, so if anything goes wrong, you can always go back a version, and you can just make sure everyone is able to work together. Yeah, thank you for coming. I hope you have a fun time, and I wish you luck on all your different projects. Good night.